Within the Software Design and Development Unit of National 5 Computing Science, you need to be able to rewrite code to make it more efficient. In this video, we're going to look at a number of exam-style questions that ask you to do exactly that. Here is our first question. Wendy is organising a school prom and has written a program to collect the names of pupils attending and to print name cards for each table. A total of 100 pupils can attend. The code to receive and store the data for the pupils in the array is time-consuming to write and difficult to maintain. Write, using pseudocode or a programming language of your choice, the code to show how the data can be entered into a 1D array using repetition. Before I go through this, you may want to pause the video and attempt to answer this question yourself. So, let's have a look at how I would go about answering this question. Firstly, let's examine the code that we've been provided with. On line 5, we declare an array called pupil. Then, on lines 6, 7, 8, 9, and all the way through to 106, we populate the array. So it's line 6 to 106 that we are going to rewrite. And we're going to use repetition to enter these values into a 1D array. Now you can write your solution in a programming language or pseudocode, and I'm going to use pseudocode. Because we're using an array and we're going to do the same thing 100 times, we're going to use a loop. And we're going to loop 100 times. Within this loop, we're going to get a name. We're then going to take that name and add it to our array. And then we will end our loop. So there we have a solution that uses a loop to add 100 names into an array. So this question is worth 3 marks. I imagine that we get 1 mark for indicating that we are using an array. We get 1 mark for the user input, and then we get 1 mark for adding the value to an array. Now, of course, there is more than one way to write the pseudocode for this program, so your pseudocode may look slightly different to mine, but providing you've got the 3 points I've illustrated there, the loop for 100 times, getting the name from the user, and adding the name to our pupil name array, you're likely to get all 3 marks. Moving on now to question 2. The following section of code calculates the total calories eaten for a 7-day period. When evaluating this code, it is found to be inefficient. Using a recognised design technique, rewrite lines 1 to 8. Pause the video now and have a go at answering this question. So here's how I would go about answering this question. Clearly, we are going to be doing the same thing 7 times, getting the number of calories. We're then going to take each calorie and add to a total. So here we have an example of one of our standard algorithms. This is going to be a running total in a loop. So with a running total in a loop, we first define our total calories. And because we've not started asking for the user input, our total calories are 0. Then we need to loop 7 times. And each time we go through a loop, we need to get the calories from the user, and we add the calories to our total calories. And there we have a partial solution. You might think that this is a complete solution, but in fact it is not. To identify the parts of the solution that are missing, we need to look at step 9. On step 9, we are told to display the total calories along with the calorie values. So in order to display the calorie values, we need to store the 7 values that we have entered into our program, which means this program is going to need to use an array. So before our loop, we are going to create calories array, and then each time we get the calories from the user, we're going to add calories to our calories array. So this question is worth 4 marks. So we're likely to get 1 mark for initializing our total, and then 1 mark adding the calories to our total. We'd get 1 mark for the loop, and then the likelihood is the last mark would be for using the array. Now, whilst it's not in this question, we could have a look at how we perform step 9. We want to display the calorie values and the total calories. So again, this is another example of one of our standard algorithm. This is going to be a traversing 1D array algorithm, whereby we loop 7 times with a counter, and each time we go through the loop, we display the calories array at position counter. And lastly, let's look at question 3. A guitar shop sells guitars and accessories. When recommending a size of guitar to play, staff at the guitar shop use the following table. Using a design technique of your choice, design an efficient solution to the problem of finding the correct size of guitar. Pause the video now and have a go at implementing an efficient solution. To solve this problem, our program is going to make a number of decisions. Before we get started, we're going to assume that the age has already been collected from the user and it is valid, meaning that it is greater than or equal to 0. So, if the age is greater than or equal to 0 and less than equal to 5, the size of the guitar is going to be quarter. If the age is greater than equal to 6 and less than equal to 8, then it's going to be half. If the age is greater than equal to 9 and less than equal to 12, it is going to be 3/4. And if the age greater than equal to 13, then it's going to be full size. So there we have a solution that solves this problem. However, the question explicitly states that we need to design an efficient solution. The solution that I have implemented here is not efficient. I'll give you an example. If we specify the age of the customer is 11, we firstly check to see if age is greater than equal to 0 and less than equal to 5, which is false because it is not. We then check to see if age is greater than equal to 6 and less than equal to 8, which it is not because it's 11. We check if the age is greater than 9 and less than equal to 12, which is true. So we've found out an 11-year-old will get a 3/4 size guitar. We then go on to check to see if the age is greater than 13, which is false. So whilst I reach my answer here at 3/4, I still keep going down to check the last if statement. So in order to make this solution more efficient, we can change our if statements to use if-else statements instead. If the age is greater than equal to 0 and less than equal to 5, and then for the next one, we can change it to else if, and for the next one, we can change it to else if, and for the last one, we can change it to else if as well. So we have made our solution now slightly more efficient, but it's still not the most efficient solution. We've assumed that the age of the customer is valid, so it is already greater than 0. So we do not need to check to see if the age is greater than 0 in our first if statement. In our second if statement, we do not need to check to see if it is greater than equal to 6. If it were not greater than equal to 6, the first condition in our if statement would be met. So we can get rid of our first condition here. We can also get rid of our first condition on the second if statement. And lastly, if it is not quarter size, half size, or 3/4, it has to be full size. So we can remove the last if and make it merely else. Let me quickly tidy up this answer to show you the most efficient solution to this problem. So here is the most efficient solution. Let's now run through it again with our example piece of data of 11. So we get the age of 11. If the age is less than 5, which is false. If it is less than 8, which is also false. If it is less than 12, which is true. So we've worked out that an 11-year-old has a 3/4 size guitar. And because we've worked out the size of a guitar that an 11-year-old has, we stop and we do not need to run the last condition within our if statement. Now that I've shown you how to rewrite code to make it more efficient, why don't you attempt the questions on screen now?